Here we want to do an illustration of Rolle's theorem. And Rolle's theorem says that if we have a function that is continuous on the interval on the closed interval AB and differentiable on the open interval AB, and if f of A is equal to f of B, then there is at least one number C in the open interval AB such that the derivative at C is equal to 0. And so let's illustrate this theorem with the following example. So we have the function f of x equal to 0.5x squared plus 2x minus 1. And this is what the graph looks like. This is the graph for f of x equal to 0.5x squared plus 2x minus 1. The derivative will be 0.5 times 2x, which is x. The derivative of 2x is 2. If we look at the graph from negative 6 to 2, so this is A, this is B. We see that the graph is continuous from the interval from negative 6 to 2. So this function is continuous on the interval on the closed interval from negative 6 to 2. And the derivative is x plus 2. And so on the interval from negative 6 to 2, the derivative exists for every number from negative 6 to 2. So this function is differentiable on the open interval from negative 6 to 2. One of the conditions in Rolle's theorem is that f of A must equal to f of B in order for the number C to exist. And so now let's verify that f of A is equal to f of B. For this example, A is negative 6, B is 2. And so f of A is just f of negative 6, and so we just plugged in negative 6. So we plugged in negative 6 and simplify, we get 5. F of A is f of negative 6, which is 5. And then f of B, B is 2. And so f of 2, we just plugged in 2. And we get 5. So f of A or f of negative 6 is 5. F of B or f of 2 is 5. So we have f of A is equal to f of B. And so Rolle's theorem says that if f of A is equal to f of B, then we can find a number between negative 6 and 2 such that the derivative at that number is equal to 0. And so here's how we find the number C. If we look at the graph, this is the point negative 6, 5. This is the point 2, 5. This is the secant line connecting the 2 points. This line is horizontal, therefore the slope of this secant line is 0. And we can see it here also. F of B is 5, f of A is 5, so 5 minus 5 is 0. And 0 divided by all of this is 0. And so that number C will be the C such that that corresponds to a tangent line that is horizontal. So to find this number C right here, we have f prime of x, or the derivative of f is x plus 2. And so the derivative at C will be just C plus 2. And then we want this to be 0. So we set C plus 2 equal to 0. And then solve, and we get C to be negative 2. And so negative 2 is in the open interval from negative 6 to 2, and f prime of negative 2 or f prime of c is equal to 0. And so the number c we're looking for is negative 2. If we look back at the graph, negative 2 is right here. This is c. The tangent line corresponding to c is horizontal, and therefore the derivative at c at negative 2 must be 0.